Hi students, let's look at this new concept here, which is what we call connected rate of changes. This part of the application of differentiation is something which usually students struggle with, but don't worry, it's not really something which is like very hard to master. You just need to understand the concept behind it. Okay, so what is connected rate of changes? Connected rate of changes is if given two variables, for example, if you have a circle and its radius, okay, a circumference, the circumference and the radius, they are related. Now, if the radius is increasing at, let's say, 0.2 cm per second, then the question would be, what would the circumference, the rate of increase of the circumference be? So many times variables are connected with a formula, okay? So when one variable changes, we want to know to what extent the other variable changes. Okay, so that's why the connected rate of changes it will be confusing. I understand if this is the first time doing this part here, but what you need to know is this chain rule here. So just remember this formula here. Just remember this is a very useful formula. Just make sure that this is empty. This is what you need to fill up. Right, so later I'll show you how to actually use it. This is nothing, this is just like a chain rule, right? So if let's say this is dv, this will be dv. If this is du, it will be du. So let's see how we can do this part here proficiently. So you're given that the radius r of a hemisphere is increasing at this rate, okay? Hemisphere is increasing at this rate. So hemisphere is essentially, let's see what is hemisphere. Hemisphere is half a sphere, right? So this is half a sphere. Let me just draw half a sphere out, okay? So this case here, I'm just going to draw this hemisphere like that. Okay, so this hemisphere here is given that this r here, this is increasing at this constant rate. So this is dr dt. R, the radius r, right? This is dr dt because that is the rate of increase. Dr dt is equals to positive 0.5 cm per second. Okay, just remember that. It's positive because it's increasing, so it's positive. Okay, decreasing will mean negative. Now find the rate of increase of volume of the hemisphere when r is equal to 3. So how do we do this? Now remember, volume of hemisphere is v. If you want to find the rate of increase of the volume, meaning you are told to find dv dt. What is dv dt? Okay, remember that, huh? Now, when r is 3, meaning at the boundary condition, this could only be sub at the end there. Now remember, this hemisphere, the r is actually increasing at 0.5 cm per second, meaning after 2 seconds later, after 1 second, you have 0.5 cm, right? You have 0.5 cm. If 2 seconds pass, you have 0.5 times 2, which is actually 1 cm. And you have 3 seconds pass, you have 0.5 times 3, which is actually 1.5 cm. So that's the idea between there. So meaning it's like there's a speed in terms of the way it increases in its length, right? So the question now is, what is dv dt? Right? So what I'll suggest is just put the step number 1 is to put this dv something times dt, just like what we did just now here. This is what we need to find. So dy something over dy something. So this is it, right? Now the next part is to figure out what to put here, because you have already been given dr dt here. So just remember, you have dr dt, so it only makes sense for you to put dr. If you put dr here, you need to put dr here. Chain rule, you need to be able to balance it, right? So we already have got dr dt here. So just remember, this is dr dt. In other words, this part here is 0.5 cm per second. We have this is a constant rate. Now dv dr, on the other hand, what we need is actually the volume. This tells you need to find v, the volume of hemisphere, in terms of r. Okay, so that's what I'm going to do. So the volume of hemisphere is actually half of a whole sphere. Sphere is 4/3 pi r cubed. Okay, so this will be 2/3 pi r cubed. The volume of hemisphere. Okay, vol of hemisphere. Okay, you go. There you go. This is v equals to 2/3. So what we need to do is actually just find dv dr. So differentiate v with respect to r. This will be 2 pi r squared. 2 pi r squared. There you go. So this is actually, so dv dt will be 2 pi r square times 0.5. Cool. So this is how you find your dv dt. Dv dt in this case here. Okay. So in other words, we have dv dt as this 0.5. This is to be 1.1. It just be 1. This is pi r square. Okay. So that's it. Now this is dv dt in terms of r. So at r equals to 3, when this is equals to 3, when the radius is 3, what is the rate? The volume, the rate of change of volume. So when r equals to 3, just like when you replace at the very end, right? You always replace the boundary condition for x and y at the very end. dv dt is given by pi 3 square, and this should be cm cubed per second. Okay, please put the units behind. So this would be 9 pi cm cubed per second. Just remember that. Okay, so this is how you do this question here proficiently. If you have any question or comments, please let us know. Keep practicing, and I will see you in the next question.